Hello everyone, this is Dr. Ian. For today, we're going to be working on how to graph our quadratic equation to its vertex form. So we're going to learn how to convert our standard form of the quadratic equation into its vertex form using the completing the square method. So for today, we're going to be working on a new form of quadratic equation so that we can draw the quick sketch of our quadratic function and its parabola by using its vertex. So from our previous lesson, I've worked on problems involving quadratic equation and we're able to solve using algebra for the solutions of our quadratic equation and the vertex of our quadratic equation using the formula. So let's have a quick review on how we sketch the graph of x squared plus 2x minus 15 by finding its solution and finding its vertex. Now we know that to find the solution of any quadratic equations, we can do this using three methods. It could either be factoring, completing the square, or using the quadratic formula. And for today, since we know that x squared plus 2x minus 15 is a factorable quadratic equation, we'll be able to set this to 0. So the function is now 0 equals x squared plus 2x minus 15. And by factoring, all we need to do is to find the factors of negative 15 that will give us positive 2 when we add them up. And those factors would be negative 3 and positive 5. So our factors is x plus 5 times x minus 3, and by using the zero product property, we'll be able to equate x plus 5 equal to 0 and x minus 3 is equal to 0. So we have these two equations, and now we can find the value of x. Forgive me for the other set of factors because I forgot to change it into positive or negative 3, but it's supposed to be x minus 3 equal to 0, so that our solutions will be x is equal to negative 5 and x is equal to 3. And this will be the solutions that we're going to be using because we know that the solutions of our quadratic equation would be the point of intersection of our parabola on the x-axis. Now we just need to find the vertex of our parabola using this formula. So to find the x-coordinate, we need to use negative b all over 2a. And to find the y-coordinate, we simply substitute our x value to the quadratic equation. So we'll find the y-coordinate of our quadratic equation. So let's have a is equal to 1, b is equal to 2, and c is equal to negative 15 for the coefficients of our terms in our quadratic functions. So by using the formula, we'll have negative 2 all over 2 times 1. And we know that the x-coordinate would be equal to negative 1, which is also our axis of symmetry. And to find the y-coordinate, we simply substitute negative 1 to our quadratic equation x squared plus 2x minus 15. And by doing the math, we have positive 1 minus 2 minus 15, which is equal to negative 16. So our vertex is at negative 1 and negative 16. And now we're ready to graph our quadratic equation by plugging in the solutions, which is the x-intercepts of our parabola, and the vertex is at negative 1 and negative 16, and we know that it's opening upward because our quadratic term is positive. So the graph of our quadratic equation is going to look like that, which we're able to sketch by locating and, of course, calculating for the solutions and the vertex of our parabola. But for today, what we're going to do is we're going to introduce a new way on how to draw the quick sketch of our parabola, and this is the vertex form of our quadratic equation. So the standard form, as we all know, is ax squared plus bx plus c, and the vertex form of our parabola, which we're going to be using today, is going to be a quantity x minus h squared plus k, where h and k will be the vertex of our parabola. So how are we going to use the vertex form to draw the quick sketch of our parabola? So let's have an example of y equals x minus 1 squared plus 1. So to be able to graph this, we need to first identify our vertex. And the vertex can be found by referring to our vertex form of the formula. And to find the vertex, it's opposite of h and k. And in this case, opposite of h and k would be opposite of negative 1 and 1. So we'll have positive 1 and 1 for our vertex for this particular parabola. So the vertex here is opposite of negative 1 and 1. So vertex is at 1, 1. So keep that in mind so that you will avoid confusion on how to write the vertex of your quadratic equation using this form. It's always the opposite of h and k for the vertex in this particular form. So by graphing it, we will locate 1 and 1, and positive 1 and 1 is on the first quadrant. And we know that this parabola is opening upwards because our coefficient or our quadratic term is positive. So this is the quick sketch of our parabola using the vertex form of our quadratic equation. So let's say we have y equals negative quantity x minus 1 squared plus 1, and we're going to use the new technique that we have learned to find the sketch or draw the sketch of our parabola. So by using our vertex form, opposite of h and k, and we know that our vertex here would be opposite of negative 1 and 1. So it's the same as the first example. It's still at positive 1 and 1. Now, what we need to do is to look at our quadratic term or the value of a, which is negative 1. So since we have a negative outside of our parentheses or our quadratic term, our parabola is going to open downward. So even though the location of our vertices for 1 and 2 are the same, the graph will be different because its behavior is now going to go downwards because the quadratic term is negative, which is what we know from our previous lessons as well. So now that you are gaining confidence on how to use the vertex form of the quadratic equation to locate the vertex of our parabola, let's have the third example of y equals quantity x plus 2 squared minus 3. And we know that this is in vertex form. So by locating our vertex, all we need to do is recite it in your head, opposite of h and k. And the opposite of positive 2 is negative 2, and k is negative 3. So the vertex here, without confusion and with confidence, is going to be at negative 2 and negative 3. So now that we have our vertex, all we need to do is to draw the quick sketch of our parabola at negative 2 and negative 3, which is at the third quadrant, and the parabola is opening upwards because our quadratic term or our a is positive 1. So this is how we use the vertex form of our parabola so that we'll be able to have a quick sketch of our quadratic equation. But the heart of this video lesson is converting our standard form into its vertex form so that we can apply this technique to draw the quick sketch of our parabola without computing for the solutions and the vertex of this quadratic equation. And how are we going to accomplish that? We're going to accomplish this by converting x squared minus 6x plus 13, which is in standard form, into a quantity x minus h squared plus k by using completing the square technique. And if you need to remember how to complete the square, the videos for that lesson is in the description box below. So make sure that you know how to complete the square so that you'll be able to appreciate this technique better. So that's the main ingredient and the key in working out a problem similar to this one so that we'll be able to graph our quadratic equation using the vertex form of this function. So let's start working with our completing the square technique. So the first step in completing the square is Transferring our constant to the other side of the equation, so we subtract 13 on both sides. So we'll have x squared minus 6x plus a box equal to negative 13 plus a box. And the reason why I put a box right there is so we can place our magic number, just like what I always tell my students. And this magic number is really not a magic, because all we need to do is to find half of the middle term and square it, so that we'll be able to create a perfect square trinomial in our quadratic equation. So a perfect square trinomial, I'm going to show you what it is if you have forgotten what it looks like in a little while. So by using this little formula right here, which is half of the middle term square, the middle term is at negative 6, so half of negative 6 is negative 3. And squaring it is going to give us positive 9. So our equation is going to be positive 9. So even though I put positive 6 instead of negative 6 in the formula, it will still become positive because we're going to square our middle term after getting half of it. So now that we have our magic number, all we need to do is to add it to our modified quadratic equation. So we add 9 to our quadratic equation and add 9 on the other side of the equation, because we need to balance things out in algebra. So make sure that when you add a constant on the left side, you need to add the same constant on the right side, so that in essence, we are not changing the value of our equation. We are just modifying our quadratic equation. And the reason why we're modifying it is because we're trying to produce a PST. And a PST is x squared minus 6x plus 9. And PST is short for perfect square trinomial. And why is it a perfect square trinomial? Because if we factor out a 9 and add them up to find that factor, it will give us this particular set of factors, and you will notice that they are identical, and they are called the perfect square trinomial, because if we simplify x minus 3 times x minus 3, we can square it and creating a square of our binomial. So negative 13 plus 9 is equal to negative 4, and now we are nearing to our vertex form of the parabola, because all we need to do is to convert x minus 3 times x minus 3 into x minus 3 squared, because that's the simple version of our square of binomial. And by adding 4 on both sides, now we have x minus 3 squared plus 4 equal to y, which you will notice is the vertex form of our parabola. So now that we have our h and k, all we need to do is to pick the correct vertex opposite of h and k. So opposite of negative 3 is positive 3 and k is positive 4. So the vertex is at positive 3 and 4. It's supposed to be positive 3 and positive 4, not negative 4. So forgive me for that little error right here. So it's supposed to be positive 4 and not negative 4. And if we're going to graph this particular parabola, we'll be able to produce the parabola opening upward. So it's supposed to be on the first quadrant, not the fourth quadrant. So forgive me with this little error. This is my mistake. So we'll have 3 and positive 4, not 3 and negative 4. So the parabola is still going to go upward. So we know that this sketch right here is the parabola or the vertex form of our parabola. And again, make sure that you are choosing the right vertex and you're not committing any errors, just like what I did in this particular presentation, which is not supposed to happen. So keep that in mind, and to be able to get out of this little mess, which is a perfect way of teaching you how to make sure that all your little steps are correct, let's answer our new problem, which is x squared plus 4x plus 5, and let's find the vertex of this quadratic equation by using the vertex form of our parabola. So let's start our completing the square technique. So we have y is equal to x squared plus 4x plus 5. So all we need to do is to use the completing the square technique. So let's set it to 0. And let's start our completing the square method. X squared plus 4x plus 5 is equal to 0. So we are going to transfer our constant on the other side of the equation, so that we'll have x squared plus 4x plus a box equal to negative 5 plus a box. And the number that we need to replace the box with to create a perfect square trinomial is going to be half of 4 and then squaring it. And half of 4 is 2, and 2 squared is 4. So the magic number is positive 4. That will help us produce negative 5 plus 4 is negative 1. And this will help us produce a factor of quadratic equation that is a perfect square, because the factors of 4 that gives us 4 when we add them up will be both positive 2. Not 4. Positive 2 equals negative 1. So we know that they are identical, so we can still further simplify this into x plus 2 squared equals negative 1. And now that we are close to our vertex form, we just need to add 1 on both sides. So we have x plus 2 quantity squared equals, not equals, plus 1 equals our function y, or equal to 0. So now that we have our vertex form, we'll be able to find the vertex of our parabola because it's opposite of h, so negative 2, and k, which is positive 1. I know that this is correct because I double checked this. And I know that the vertex of our parabola, by converting our ax squared plus bx into its vertex form, will equal to x plus 2 squared plus 1, which is the same as our equation right here. And the vertex is now at negative 2 and positive 1, which is what the vertex that we calculated in this particular form. So now that we have the vertex, all we need to do is to draw the quick sketch of our graph. So let's draw the quick sketch of our graph by using its vertex. So we know that the vertex is at negative 2 and 1. So this is our xy plane, negative 2, 1, 2, and positive 1, positive 1. So this is where the vertex is. And the vertex is opening upward because it's positive. So this is now the graph of our, or the quick sketch of our parabola using the vertex form of our equation, which is similar to what I have here in our answer. So we know that to be able to accomplish this task, you need to know how to complete the square and make sure that you choose the correct vertex form and not the wrong one, just like what happened on the previous example. So for this particular lesson, my challenge to you is, of course, let's see if you can find the vertex of this quadratic equation by converting our parabola from the standard form of the parabola into its vertex form. So again, when we are working with functions or quadratic functions, we have two methods that we can use to draw the quick sketch of our parabola. We can either find the solution and the vertex using the formula from the standard form of our quadratic equation, or use the vertex form by completing the square technique. And to be able to do that, you need to know how to perform the completing the square technique, and the video is in the description box below. So make sure to watch and review how to use the completing the square technique so that you can apply this to convert our standard form into the vertex form of our parabola. This is Dr. E, and see you again next time. Bye!